One of my favorite pastimes from when I was younger was when my parents used to dress my brother and I both up into really weird costumes. Exhibit A and Exhibit B. I know, kind of a really weird way to dress kids up and make them look like a sandwich, but one of my other favorite pastimes though was actually building things out of Lego. I was a Lego queen. I used to build anything out of Lego. Lego towers, Lego kingdoms, mansions. I think I even built a little moat at one point with the whole water. It was really great. And so I started having an obsession with building things. I loved seeing how things would be put together. I loved seeing final products of things. I loved kind of seeing the journey of things. And that's when I started learning about all these different exponential technologies. Things like virtual reality, gene editing, artificial intelligence really captivated me as I grew up because they're all kind of putting things together and creating different products, exactly like those Lego towers or Lego mansions that I used to build. And that's when I fell upon a really special emerging technology, 3D printing. One of the reasons why I love 3D printing so much is exactly why my childhood me loves putting different things together and seeing things be built. You're literally taking a bunch of different materials, putting them together and seeing them being built layer by layer to create a product that even could save a life. We're seeing so many different new applications in 3D printing, like 3D bioprinting, rapid liquid printing, crazy stuff that's out there. And today I'm going to be breaking down a little bit of the bioprinting process and how we can actually use these different 3D materials to hopefully save a life. Many people get really fascinated by the products that come out of 3D bioprinting or 3D printing in general. Seeing different models, seeing how we can literally print things up in hours or even minutes now with new techniques. But let's actually dive into what happens behind the scenes and the true process of where we can get to that point where we 3D print a model. Now, the process that I'm going to be explaining today is the 3D bioprinting process. There are many different phases of 3D bioprinting, including pre-bioprinting, the actual bioprinting part, and post-bioprinting. Pre-bioprinting is actually creating the digital model of what you're going to print. So whether it's an organ, this can also be using conventional 3D printing techniques where you're just caking up the digital layer and you can use different computer softwares to do so. The actual bioprinting part is connecting all these different materials and basically building up a model or an organ layer by layer. And post-bioprinting is mechanical or chemical simulation of the actual organ or whatever your product is at hand to make sure that it fits in to the body and adapts to the body structures. But for the purpose of this video, I'm just going to be focusing on the pre-bioprinting phase, so the compiling of the digital model and what I made, as well as the actual bioprinting process. Now, to dive a little bit into the pre-bioprinting process, this is basically where you compile your model and get all your digital assets together to construct an organ or whatever it is that you're printing up. I'm going to be talking about how it applies to bioprinting specifically, since the video is about the bioprinting process and different materials and the specifics involved. But you can use multiple different softwares to basically create models. I want to take you guys through the step-by-step of how I was able to do it, specifically using the Autodesk software. Autodesk is an amazing company that specializes in 3D printing technologies. Autodesk really specializes in a bunch of different 3D modeling softwares and computer-aided design softwares, CAD or CAD for short. Basically, these softwares allow you to model different 3D models and makes it really easy for you to print up. The ones that I used specifically were Fusion 360 and the AutoCAD software. To create different models in the bioprinting process, there are multiple different materials that are included, and multiple materials that are also printed out by bioprinters that are compatible with different models and ways of shaping things. It's a huge area of medical research, and I'm going to dive into a little bit of the different materials that are printed up through the bioprinting process and why they're a huge asset to the medical. A really good example of a material that's printed using conventional 3D printing techniques, which basically means really basic 3D printers, 3D printing techniques, is silicon. Silicon is often printed up as it's pretty biocompatible and tear resistant, making it a good option for research in medical fields, clinical trials, and etc., especially for patients that need customized implants, whether it's dental implants or even building new prosthetics and kind of combining the different fields of neurology, nerves, with different sciences, and etc.
Other applications can include things like skin contact products such as respiratory masks, hearing aids, headphones, wristbands, and one of the biggest applications would be attachments for wearables, actually, for monitoring devices. So doctors can keep track of their patients through a long distance by actually monitoring their pulse and how their heart is working or how the different parts of their body is working. And the wearables can really help them to do that. And silicone is a material that's usually involved in these and kind of installed in them, since it doesn't really create much of a tear and it's really biocompatible. The main components of a silicone 3D printer include the printer base, the silicone extruder, so the actual material that comes out to make the silicone, the pump, and the actual cartridges.
Now, you're probably wondering, well, in the bioprinting process, they can't just use things like regular ink, like in conventional 3D printing, because you're actually printing up a live model that can be put into a body or used for more than just the model is when it's printed up. And you're right, there are multiple different materials that, like I said, are involved, like silicone or synthetic polymers, but bioinks are also a huge part of this. To shift gears a little bit, let's talk about the actual bioinks that are used to produce these 3D models. It's kind of like the ink that you have at home for either inkjet printers or other printers that fill up the cartridges, but specifically tailored towards bioprinting. Bioinks are a combination of living cell filaments and a compatible base. Now, the living cell filament can include anything, even up to stem cells. We're now trying crazy things like extracting stem cells for things like bioengineering or personalized medicine. This could be used in a vast area of medical research for 3D models when we're printing them up to make sure that they're personalized to the patient's body to prevent rejection. And the other part of this combination is a compatible base. So this can include anything like gelatin, collagen, or silk, which I'll explain in a minute. Bioinks are really known as the filament of 3D printers because they're used to replace the normal ink that are used to print up basic models through conventional 3D printers and their cartridges.
There are three main categories that bioinks for bioprinters usually fall into: matrix, sacrificial, and support. Matrix bioinks can include any type of biomaterials that's used for living cell filament, or in other words, any bioinks that's used to put into cartridges of bioprinters. Now, along with printability, there are different factors that are also involved in making these bioinks really sufficient and effective. These inks offer a really compatible environment for living cells to foster and grow and allow for nutrients and waste to transport when the model is actually being used in the body effectively. It is usually composed of cells, but oftentimes an additional material that gathers all the cells is also part of the ink. This material uses a biopolymer gel, which acts as a 3D support for the model while printing it up, almost like a base or a second structure for support. Cells are used to attaching to this gel, and that allows them to spread while printing up the model. So I've 3D modeled and printed organs like lungs before. So the process is pretty similar to that of 3D modeling other organs, but this is specifically towards hearts. Using the Autodesk and Fusion 360 software, I was able to model my own version of a rabbit-sized heart. I started off by sketching the lungs in 2D and extruding them into a 3D version, which is basically what Fusion 360 is known for, taking 2D sketches and converting them into 3D forms, using the origin workplane that you're given. Most Autodesk and 3D printing softwares have something called a drag and drop system, but with the Fusion 360 software, objects are often customized by developing them in a 2D form first, so basically sketching them out, and then actually customizing them into 3D models, so adding features, specifics, all that kind of stuff. I also tested this out with the original Autodesk software called AutoCAD by uploading and creating the models for 3D hearts using that drag and drop method. Now, the reason the modeling stages are so important is because with bioprinting or conventional 3D printing, we can actually print up models that have defects in them if we don't take care of that or of those defects during the modeling process. This is pretty detrimental to any bioprinting process if we're printing up live organs with things like stem cell implants or living cell filament, because it can result in a badly used organ. In this step, the 3D printer reads the design from a 3D digital file and lays down different layers of materials, such as bioinks or hydrogels, things that we talked about before that are used to print up models from a series of different cross-sections, layer by layer. The 3D printed object can be finished according to the modeling, and a lot of 3D printing techniques are capable of using multiple different materials in the course of constructing the parts, building the parts to create the model.
You can now see that 3D printing is nothing but taking a bunch of different materials and putting them together. But the outcome, the product of that, is actually being able to save a life. I personally went from building towers out of Legos and building blocks to building something layer by layer that could help someone else, that could replace someone else's damaged organ within their body. and that's really, really cool. 3D printing is basically taking what is in our heads, our imagination, and turning it into a reality where patients can now not rely on anything else except for their own bodies and technology to be able to help them.